Welcome to this presentation on the subject of the ISA99 Committee for Industrial Automation and Control System Security. The information in this presentation is current as of January 2015. Our purpose is to introduce the ISA99 Committee as well as the ISA 62443 series of standards on industrial automation control system security for which the committee is responsible. My name is Eric Cosman. I have over 35 years of experience in the field of industrial information technology. I am a charter member and the current co-chair of the ISA99 Committee. I'm also the past Vice President of Standards and Practices at ISA, as well as a member of the ISA Executive Board. This presentation addresses several topics. We'll begin with a short description of the committee, its scope and its purpose, including how this purpose fits with the larger context of all ISA standards and practices. From there, we will move on to describe a little bit of how the committee is organized and managed. Each of the above items will be kept short on the assumption that most people are less interested in the details of how standards are developed than in their content and how it may be applied. With the third topic, we begin to discuss the content of the committee work products. This begins with a summary of the basic concepts that form the foundation of this content. This is followed by a description of how we have structured and organized a set of standards and practices, each addressing a specific area or aspect of the subject. This includes a discussion of how the various parts are related and the interdependencies between them. In order to get a real appreciation of the status of the work in this area, it is necessary to review some of the recent or current developments. As with any large effort, there are many moving parts, and it's sometimes easy to lose track of recent activities. In our last topic, we will look forward both in the short and long term. This section describes some of what we see coming as well as some of the challenges that we face in order to continue to make progress. Finally, I will leave you with some contact information that you can use to reach out with any questions or comments you have on the committee or its work. So exactly who is this committee, where did it come from, and who are the people involved? Perhaps the more interesting question here is, what is the committee trying to achieve? First, let's take a bird's eye view of the committee from the outside. Established in 2002 with a small handful of interested people, the committee has since grown to a membership of over 500 people. These members come from virtually all industry sectors, although some are definitely more heavily represented than others. Contrary to what you may have heard, the focus of this committee is not limited to any sector or specific industry type. We welcome membership, participation, and contribution from anyone with an interest and experience in cybersecurity needs of their respective constituency. Also, our membership is global, consistent with the global reach and scope of the International Society of Automation. The place to start is with an understanding of the scope that we have defined for our efforts. This has remained essentially unchanged since the committee was formed. It was deliberately stated very broadly so as to provide a solid security context for a wide range of automation-related areas. As you can see, we have focused our scope definition on anticipated or potential consequence. These consequences including endangerment of public employee safety, environmental protection, loss of public confidence, violation of regulatory requirements, loss of proprietary or confidential information, economic loss, or impact on entity, local, state, or national security. Such a broad scope brings in a correspondingly broad set of stakeholders, and that only serves to increase the value of the resulting standards. Certainly, cybersecurity failures are not the only potential source of these consequences, but they may be the least understood in terms of the general engineering community. Without going into a lot of details, let's spend just a few moments on how the committee operates. A full and detailed answer to this question is a complex subject in itself, but one that is really only of interest to a smaller community of stakeholders, consisting of those who actively participate in the committees. For our purpose today, we will focus on a few specific details that are important for our general stakeholders to understand. To begin, let's spend a few minutes on the relationship between the ISA99 Committee and committees and work groups of other standards development organizations, or SDOs. In addition to ISA, there are at least 2 other SDOs with an interest in developing cybersecurity standards in this space. The first of these is the International Electrotechnical Commission, or the IEC. When the ISA99 Committee was formed, there was an agreement between the ISA and IEC to cooperate on the development of cybersecurity standards. This would avoid the need to create duplicate committees in each organization. As a result of this agreement, the ISA99 Committee is charged with developing the majority of standards and practices in the 62443 series. These will be issued by ISA with numbers of the form ISA 62443-X-Y. At the same time, or shortly after, the intent is essentially the same standards to be issued by the IEC with numbers in the form IEC 62443-X-Y. There is one specific standard in the series so far that is being developed first by IEC. The plan is for ISA to adopt it as an equivalent ISA 62443 standard. Finally, the ISA99 Committee is also working closely with a Joint Technical Committee, or JTC, of ISO and IEC to ensure that our standards are consistent with the general cybersecurity standards in the ISO 27000 series. These working partnerships can be complex and sometimes difficult to manage, but the result is less duplication of effort and ultimately less confusion and more consistency for the ultimate users of these standards. In addition to the previously mentioned formal relationships between the SDOs, the committee also maintains liaison relationships with several other committees and groups, both within ISA and externally. In the case of ISA committees, recall the decision to centralize the development of cybersecurity standards into a single committee. This requires that the committee work closely with other committees to ensure that their perspectives and needs are adequately addressed. Examples of this include a relationship with ISA 84 on process safety and ISA 100, which addresses wireless communications. In both of these cases, the security aspects of their subjects have to be addressed in the ISA 99 Committee. Within the Automation Federation, we also work closely with the Industrial Security Compliance Institute, or ISKI, to ensure that the ISA Secure certification program remains consistent with the contents of our standards. In addition to the ISA and the Automation Federation, we also maintain relationships with external groups, such as the Industrial Control Systems Joint Working Group, and various sector-specific groups and government initiatives, such as the people working on the NIST framework. We are always looking for other liaison groups or relationships that have to be formed in order to make sure that our standards are relevant and useful to as broad a range of stakeholders as possible. Finally, as already described, we maintain active relationships with IEC and ISO to assure global adoption and consistency. Moving on from the committee structure and processes, let's take a look at the content of the standards. We'll start with the basic concepts which provide the foundation for the series. These concepts are in turn divided into 2 groups. The first of these groups include concepts that are related to general purpose information system security. These concepts are equally applicable to industrial control system security. The second group includes concepts that have specific or unique characteristics or have to be applied in specific or unique ways in the domain of industrial control system security. We'll spend a little bit more time on these. Effective cybersecurity for industrial automation and control systems is an extension or enhancement to that for general purpose information technology systems. Most of the established concepts associated with general purpose IT security apply in whole or in part to the IACS environment, with some needing additional domain-specific guidance or interpretation. The concepts shown on this slide are described briefly in the first standard in the 62443 series, along with comments as to the extent of their applicability in this context. In fact, the first of these concepts calls for a thorough understanding of the context for the application of security. This is followed by the necessity of establishing well-defined objectives. Least privilege is a principle or a concept that is important in an IACS environment as in any general purpose system. Individuals and roles should be assigned only those privileges and capabilities that are necessary for completion of the necessary tasks. Defense in depth is also an established concept in cybersecurity that applies well in an IACS environment. It is part of the basis for more specific zones and conduits that will be described in a few moments. The use of this method is an integral part of the threat risk assessment, also a common concept for all types of IT systems. Finally, it is critical that all aspects of the IACS security program be established and documented in the form of policies and procedures. From the general IT security concepts, we moved on to a list of what have been described as fundamental concepts, defined as those that form the IACS specific elements of the foundation for the 62443 series. Each of these is described in more detail in the pages that follow. The first of these fundamental concepts is the life cycle for IACS cybersecurity, as shown in this diagram. This life cycle is actually composed of three smaller interconnected life cycles, each devoted to a specific phase and focused on a specific class of stakeholders. The first of these phases includes all aspects and steps associated with the development of products and technology. The principal players in this phase are product suppliers. This phase receives requirements from both integrators and asset owners while providing guidelines and support for each of the subsequent phases. Once products have been developed and delivered, they are applied by systems integrators to construct complete automation solutions. This is the middle phase of the model. The requirements come primarily from asset owners who in turn receive guidance on and the support of the fully integrated system. Finally, the third phase of the model is focused on the operation and maintenance of the integrated solution by the asset owners. Requirements and expectations are derived from this experience and passed back to either the product supplier or the integrator. This model is introduced in ISA 62443-1-1 and provides a framework for most of the remaining standards in the ISA 62443 series. The second of the fundamental concepts is that of zones and conduits. It includes a series of models, requirements, and guidelines that describe how a complex interconnected system can be decomposed into a series of zones, each with a specific set of security requirements that are based on a detailed risk assessment. This concept is based on the recognition that most industrial control systems are far too complex to be treated monolithically with regard to security. One of the primary benefits of applying this concept is that of containment, where attacks can be confined to a specific subset of the overall system. The essential elements of this concept are introduced in ISA 62443-1-1, and the details of its application and risk assessment are addressed in ISA 62443-3-2. An essential element of the zones and conduits concept is that of system segmentation. Ideally, much of this analysis will have been done in the course of system design and integration. For existing systems, this information has to be developed by reverse engineering the system configuration. The various system components are described in terms of several attributes as shown here. Functional interactions and data flows are very important as they make it possible to understand the security-related differences between them. Understanding all of these attributes makes it possible to identify the security-related differences between system components. This becomes the basis for the identification of zones. These zones are in turn connected by conduits that are defined based on the information flows. This figure is an example of the application of the zones and conduits concept. Each of the bubbles corresponds to a zone, and these zones are in turn connected by conduits. A detailed description of this example is beyond the scope of this presentation. The third fundamental concept is that of security levels. Similar in some ways to that of safety integrity levels as defined in the ISA84 series of standards, this concept provides a means of determining a range of responses depending on the specific circumstances. There is one important difference between safety and security levels in that the latter are not based on a mathematical analysis of probability. Thus, security levels are more qualitative in nature, but are based on an assessment of potential consequences and the perceived nature of the attack. This concept is also introduced in the ISA 62443-1-1 standard and is applied in other standards in the series, most notably ISA 62443-3-3. As with any set of standards, it is important to have a firm basis for the definition of normative requirements. In the case of the 62443 series, much of this basis comes from the definition of the foundational requirements shown on this page. Collectively, these requirements form the fourth of the fundamental concepts upon which the 62443 series is based. The first of these requirements speaks to the need to be able to identify and authenticate users of the system. This is an established requirement at the basis of virtually all security programs. Once these users have been identified and authenticated, it is essential to define what can be done by each of them. This is the subject of the second foundational requirement. Assuring the overall integrity of the industrial control systems is also an essential need, and this is the subject of the third foundational requirement. Although data confidentiality may in some circumstances be relatively less important than in a conventional information system, it remains an essential requirement as described in Foundational Requirement 4. Data communications or transfer is also critical to the successful operation of an industrial control system, and the proper control of this data flow is the subject of Foundational Requirement 5. Similar to the situation with data flow, it is essential that the operation of industrial control systems be as deterministic or predictable as possible, including the response to various events. This is a subject of Foundational Requirement 6. And the final requirement in this list addresses the availability of critical resources. These foundational requirements are described in 62443-3. All of the detailed technical and process requirements that appear in other standards in the series derive in some manner from the items on this list. After a security program has been designed and implemented, it is essential to have a means of assessing maturity in order to identify those areas that may require improvement. This is the fifth of the fundamental concepts in the 62443 series. It is very similar to other capability maturity models such as that defined by the Software Engineering Institute. Maturity assessment is of particular importance in the standards that address the people and process aspects of the security program, such as ISA 62443-2-1, ISA 62443-2-4, and ISA 62443-4-1. At this time, this concept is still evolving somewhat as these and other standards are completed and issued. The sixth and final of the fundamental concepts is that of safety and security. Specifically, this concept establishes the basis for more detailed information and guidance with respect to how to respond to the various combinations of safety and security level. Safety is very much the reason for security in many cases, and it is important to understand the relationship between these two level assessments. Since the determination of a suitable response requires consideration of both safety and security related factors, this concept is being developed in conjunction with the ISA99 Committee on Process Safety, as well as other interested and involved parties. This includes the Safety and Security Division of ISA. In summary, the six fundamental concepts at the foundation of the 62443 series are well established, with some of them requiring additional definition and clarification. These include security levels, program maturity, and safety and security. Now that we have described the fundamental concepts, it's possible to move on to a description of the status of each of the work products in the 62443 series. All ISA committees are expected to produce some combination of standards, recommended practices, and technical reports, depending on the needs associated with the subject at hand. Of these, only standards contain normative content, generally defined as including clear and direct statements as to what must or shall be done. The other two types of work products are generally considered to include only guidance information. This graphic appears on the ISA99 website and is used to show on a single page the full range of work products developed, in development, or planned by the committee. As such, it provides the best bird's eye view of what we have produced and what we plan to produce in the future. The details of this organization change from time to time as circumstances dictate, such as with the release of a completed standard. All such changes are reviewed and approved by a vote of the committee. The first thing to note in looking at this diagram is that our work products are organized into 4 distinct groups or tiers, each with a specific focus. The first or top tier contains standards and reports that are general in nature and must be understood by the entire stakeholder community in order to successfully apply the standards. With those general concepts and subjects established, we move on to the second tier, which addresses the people and process aspects of an effective cybersecurity program. The audience of these documents includes people who develop and operate these programs across the entire cycle of solutions. With the general concepts and process-related aspects addressed, we move to the third tier, where the focus is on the technology-related aspects of security. This includes both an assessment of available technologies and their suitability for use within this context, as well as the specific requirements related to the technical aspects of a security program. Finally, the fourth tier focuses on the specific security-related technical requirements of the products and components that are used to assemble industrial control systems. The contents of each one of these tiers is described in more detail in the next slides. In the first tier, we have standards and technical reports that contain information that is common or fundamental to the understanding of the entire series. The first of these is ISA 62443-1-1, the anchor standard that introduces the fundamental concepts and models that form the foundation for the other standards in the series. The first edition of this standard was published in 2007, and a second and more comprehensive edition is currently being prepared. As important as concepts and models is a common glossary or lexicon. This need is addressed in the form of a technical report, ISA TR 62443-1-2. This report has not yet been published, but a draft is available for review and comment. Moreover, all terms and definitions used in the series are maintained on a public website for review and comment by our stakeholders. The third item in this tier is a technical report that describes the metrics required to assess the successful application of a cybersecurity program. This document has not yet been published, but is under active development. And finally, there is a technical report that describes specific use cases or examples at each stage of the cybersecurity lifecycle. These examples are being defined in the course of developing the various other standards in the series. This document has not yet been developed. As stated earlier, the focus of the second tier of products is on the definition and operation of an effective cybersecurity program. This begins with the definition of a comprehensive management system that is based on the general approach described in the ISO 27000 series, with extensions, enhancements, and interpretations as required in the industrial control systems context. The first edition of this standard was released in 2009, and a second edition is currently being prepared. In support of the management system definition standard, this tier also includes a technical report, ISA TR 62443-2-2, that provides guidance in the application of the standard. In addition to defining what is required, this report will explain how to go about preparing it. This report has not yet been completed. Patch or change management is a very important, even critical element of an effective cybersecurity management system. For this reason, the committee has created a separate technical report on the subject. In addition to describing how to effectively manage patches and changes, this report also provides a common method for the characterization of this information. The final document in this tier speaks to the security-related requirements for system and product suppliers. This is the one document in the series that has been developed by the IEC. It has been approved and will soon be available. Moving to the third tier, we start with a technical report that examines available cybersecurity-related products and technologies and their suitability for use in an industrial systems context. This report has been released and a revised edition is currently being developed. The second component of this tier is a standard that addresses the task of risk assessment during the design of an industrial control system. This is where the concept of zones and conduits is described in detail as a means of segregating functions within a large and complex system according to relative risks. This document has not yet been released, but 2 drafts have been issued for review and comment. Finally, the third element of this tier describes the specific foundation or system requirements that must be met for a secure industrial control system. This standard has been released and is generally available from either ISA or IEC. With the fourth tier, we begin to delve into the much more detailed security requirements for both the technical components as well as the processes used to design and develop them. The principal intended audience for the standards in this tier includes system and component providers. The first standard in this tier describes what is required for an acceptable product development process. This standard is close to completion and will soon be issued for review and comment. The second standard in the tier describes the detailed or derived technical requirements for components of an industrial control system. The term derived is used to indicate that these requirements follow directly from the more general foundational requirements described in ISA 62443-3-3. This standard is close to completion and will soon be issued for review and comment. With all of the above information in mind, perhaps the next logical question is, what is happening now? The next few pages provide a brief summary of recent developments and current activities, leading to a short preview of future developments. First, we will review some of the more recent developments related to the 62443 series. The technical report on the subject of metrics has long been identified as a key element of the series. In order to increase the pace of development and provide more emphasis on this product, this work has been assigned to a newly created Workgroup 12. This group is now in the formative stages. One of the committee work products that has gained some interest is the technical report on patch management. This document has been completed and all of the comments received during the review process have been addressed. It will be issued by the ISA as soon as the remaining administrative steps are completed. As mentioned earlier, there is one document in the 62443 series that has been developed not by the ISA99 Committee, but rather by Workgroup 10 of IEC Technical Committee 65. This standard defines the requirements for ICS solution providers and is based on the earlier work by the WIB organization in Europe. Work on this standard is complete and it is being submitted as an international standard to IEC. When that step is complete, there will be a vote of the ISA99 Committee to adopt this standard as part of the ISA series. Of course, there is still much work to be done to complete the series. Some of the specific areas of focus and emphasis are shown here. The first involves the development of a revised edition of the Security Management System Standard, ISA 62443-2-1, to improve its alignment with the most recent edition of the ISO 27000 standard. Another major emphasis is the development of a second edition of the Concepts and Models Standard, ISA 62443-1-1, with a specific focus on affirming and incorporating the fundamental concepts described previously. The intent is to introduce these concepts in that standard, providing the basis for more detailed treatment and analysis in subsequent standards in the series. And finally, a full description of the detailed requirements of the 62443 series is being developed in the form of product development and component standards 62443-4-1 and 4-2 respectively. Finally, a quick look at what is coming in the not-too-distant future. A great deal of effort is going into the development of several of the standards in the series. Perhaps our most anticipated standard is on the subject of risk assessment and system design, ISA 62443-3-2. Significant progress has been made on this document in the past several months, and the plan is to have a version available for review and possible approval within the next month or so. A similar situation exists for the standards addressing the requirements for product development and system components, 62443-4-1 and 4-2 respectively. Both of these standards are close to completion and will soon be available for review and comment. In review, we've seen an overview of the ISA99 Committee and its current and planned work products organized into these specific topics. Beginning with a summary of the committee and how the committee works, we moved on to the basic concepts that form the foundation of the 62443 series. This was followed by a description of each of the work products and a summary of its current status. Finally, I've given you a little bit of information about our future plans and anticipated next developments. This brings us to the end of the presentation. I hope you found this information useful and informative. But before I leave you, I would like to share with you some contact information that you can use in case you have questions or would like additional information. First of all, we have the ISA99 Wiki, which you can see here at the top of the page. This is a site where you can go and get all sorts of information about the current status of the committee, as well as some content information such as master glossary, and in some cases drafts of documents currently under development. Although not terribly widely used, we do have a Twitter account called ISA99 Chair, and from time to time we will issue updates from this account to people who follow activities on Twitter. Our committee chairs are myself and Jim Gilson. You can see our contact information here, and as well we have a general account called ISA99 Chair to which you can send information or email messages, and someone will get back to you with a response. Lastly, Charlie Robinson is our ISA staff contact, and he is probably the best source of information about procedural details and questions about how committees operate. Whenever you contact us, it would be helpful if you provide your contact information and any specifics on the area of expertise or interest or the subject that you're asking questions about.